Hello everyone. I realize I didn't explain the latest version of the port. So I will just have a quick run through. I kept the on-off switch functionality, though I don't think it's really important. I think I will bypass the switch because, to be honest, there's already a safety measure anyhow. It boots up and it starts from 5 milliseconds. As you see, it's off. It gives you the battery voltage, and if the battery voltage drops under 12, there will be a red flag here, so that will warn you. And yeah, the cutout here is actually a little bit, it's slightly smaller than the screen, so it kind of a little bit trims off, but not a big deal because what's important is in the center. So as I said, the timing is precise now. It's not shifting, not losing half or gaining a millisecond like before. And that works fine. I did several tests and it's always spot on. As you see, I added the foot switch, which is actually nice when testing, so I can put it into manual mode, and that will, if I press the switch, it'll fire. Again, let's say that I noticed that this starts working well from about 20-25 till up to 35. 35, it can weld 0.15 or 0.12. I'm not really sure. These little tabs that I had around, I ripped them off batteries, and they're pretty thick. They're not the thin 0.1 millimeter, not even the 0.12. These must be 0.15. They're pretty thick, maybe even more. Anyhow, for the point, if you press, by the way, if you press these two together, it will directly go back to 5. It's a quick way to reduce it. The electrodes here, I suggest you, let's see if it focuses. I suggest you do file them a little bit down to have a little bit more either rounded or slightly pointed. Not a sharp point. It must be blunt. But if it's flat, what you do is when you contact this, you're never contacting the weld point flat. You're always doing it a little bit. These two hand contacts are they're never like straight up. So if you have a rounded surface, it's much better because at least the contact is always basically, the surface is always basically the same. If instead you have it flat and you have it at an angle, only that little corner will make contact, and all the current will go through that corner. And while, okay, it will be more, let's say, efficient weld-wise, it doesn't give a very big surface weld. So a rounded surface, it will give you a more homogeneous weld point, and it will certainly be stronger because more surface will weld of the nickel plated, those little tabs. If you don't file it down, as I said, you keep the sharp corners and you're like welding it like at an angle. I don't know, like this, or like you can't, you would have to do it like this. But if you're doing it at an angle, only the little angle will be making the big weld, and that usually will perforate your nickel strip, which is not really good because then it won't be structural. It won't hold. So it's always better to file it off and to have a slightly more pointed, kind of like roundy and a little bit blunt. No point, just blunt. You can roll your finger over it. That's good. Instead, if you have one of those double electrodes which have a fixed angle, so you're just moving them together, that's a different story because they're stuck together. They're stuck together like this or like this, And that way, the only angle you will be giving them is your position. You should always, to spot weld, if you look, many years ago, we had one of those professional spot welders in this lab where I used to work for some time, and to make these first packs, it was even before the lithium ion 18650s. They were like usually the Sanyo or whatever, nickel metal hydride or even nickel cadmium, to make these packs for models, airplane models or whatever. And this machine was actually it had a cap, but it was transformer based, and like the ones you can maybe make from microwave oven transformers, with a very thick secondary. And there was these two very thick cables, multi-braid, coming out, and the machine would just hold them there. And there are some on YouTube. You would put the pack with the strips underneath, and there was a thick, like, I think it was about, I don't know, centimeter thick plexiglass in front of your face, and you would just, behind the plexiglass, you would put the battery and put it in position, and simply these two big electrodes, you would depress them, and then with a foot switch it would give the contact. And this machine was very powerful. I mean, it could do I don't know, it could probably do 1,000 amps, melt anything. We usually kept it on the minimum settings for welding these batteries. But anyhow, those were fixed, and the contacts, you had these replacement contacts. They were actually spring loaded, and the contact was on the spring, on the movable. It was like a coaxial contact, like this one, but it would slide into another one, and it was spring loaded. So the force on the contact was basically always the same, which is also kind of important, because if you put if you put a lot of force, okay, it's not really a big deal. But if you don't put enough force and the contact is not well made, then you will get these sparks, right? And you've seen them also when I was doing some tests. Sometimes some little piece of tab would even vaporize and fly off. You can see it fly off very violently, and it's very hot. And that's because there is no good contact. When there is good contact, all you see is a little kind of like red, orange, even whitish glow around the point. That's when it's good contact, and that's usually a good spot weld. And you can notice it because there is maybe some slight smoke, or as I said, this is glowing, and around the spot weld, the ones that I have now, I completely destroyed these, so there's not much really to show. But around the spot weld, you will get a little discoloration. I don't know, can't see it here. I did thousands of tests here, as you see. Anyhow, back to this. Electrodes, handheld electrodes like these. Maybe I can zoom out. Okay. Handheld electrodes like these are okay. But as I said, you're holding them in different positions, so give them a rounded surface. Okay? They give you these things flat, but that's not really. If you were to put them flat, dead on the contact, I would understand, but that's not the case. So round them, make them a little bit round. It will improve your weld a lot. Again, battery is important. You know what I think about LiPos and everything. So it's up to you then. And this I've tested this up to around 40 milliseconds. And it's very, pulses are starting to get very strong then, and I don't want to exaggerate too much, because I think it's more than enough. So keep that in mind. With these, I think it's 0.15. It can weld them, and it can actually burn holes through them. So I don't know. It looks pretty powerful. I've done many, and these were not even warm. Lukewarm, something like that. So Of course, I didn't do 100 welds one after the other. I usually do a few welds and would check. So as I said, this is like a mini one. It's not something that you would use to make dozens of battery packs with hundreds of batteries in, because no way. I mean, you need a professional one. But I was curious, so that's why I bought the whole this one. I said, okay, you know, why not? You have to maybe replace some laptop batteries or something like that instead of cutting them off and soldering them, risking damaging the seal, because that's another thing that I was asked. These batteries, oh, my 181650, it's, oh, just go and get one. Okay, so here are, no, this is like, comes from some old laptop, which I usually open up, and then there's usually one or two cells that are worse than others, and yeah, the tests are pretty okay. You see these contacts, they're actually pretty thick. They're not 0.1. These are 0.15 at least. They're very thin. You see these, the ones that have this little slit in the middle. If you look at the weld, yeah, you should be able to see it. If you look at the weld, you see that there is very little to no discoloration, meaning that it's very fast weld, and there is about, I would say, nearly a millimeter diameter in this weld. You see that it's also perfectly circular. Okay, they aren't either on one side or the other. You see there is a perfect, near perfect circle. That's what I was talking about. These are welded with those machines, and they are vertical. And the surface of the weld is, if you look, you can see the circle around, which is more pronounced than the center. It's slightly concave. However, it's like these ones when they arrived, they were slightly like this. However, as I said, if you don't have this machine that keeps them perfectly in vertically straight, normal to the surface, that will give you a good weld. It will puncture it usually either on one side or the other based on how you're holding it. So this is a machine welded, as you can see, battery, and they are perfectly, just two welds, and they're perfectly welded. They're very strong, and when you pull them off, usually what happens is they rip open, and yeah, you know that. Here. See on the back, these just two spots. This is the lateral one, because they were like stripped, and they're so welded well that when you pull them, actually you bulge slightly the battery. So you have to kind of like move them, and to avoid the bulging, I cut them off here. Otherwise, if you pull them, you will bulge the battery. They're welded very well. These are like industrially welded, and they're calibrated exactly for this kind of contact. Plus, the strips are spring-loaded on, and so there is no space, and it's very between the weld and the strip and the bottom of the battery. So, if you don't have a machine, you have to, of course, revert to soldering. Now, what is the problem of soldering? Now, if you solder the bottom, okay, the bottom of these batteries, they have a lot of surface, they have a lot of thermal capacity, so it's harder to solder, but they don't get so hot. And usually you can just scrape or file a little bit the plating, and it's going to solder easier. So okay, you know, you could go ahead and do that, like it's always been done, but the problem is the top. Now, and this batteries, I don't know if many people don't know, but in production, it's a long story, but anyhow, to certify these batteries for commercial use, there was a problem. You couldn't give these batteries with what is called thermal protection. Now, the heads of these batteries here, there is a little, you can see this little tab here. It's not by chance. This is what was called Polyswitch, or actually it's like an NTC. in series here, I don't know if you can see it, it's actually open. 1, 2, 3, there are like, it's not perfectly sealed. If you look here, you can see that there is a hole here, there is a hole here, and there is a hole here. Now, what this means is that this is actually not the real battery. The battery ends here, where you see my nail. On top of the same casing, to avoid explosions and everything, they had to put one of these protection circuits. Okay, it's actually, as I said, an NTC. When it gets hot, the resistance increases in series of the battery, and the battery doesn't overheat. Now, these are calibrated based on the type of battery. So I think this one was 2200 milliamp battery. It's actually a good brand. I don't remember. I got some of these many years ago. It's not really recent. But okay, some batteries that are sold also have an additional protection. If you notice this little contact here, this is a little weld. You see, what was here? There was another part of the battery was welded on, which contained an electronic circuit, and it was about 1.5 millimeters thick. I have some. I can show you them if you're interested. But anyhow, these are actually welded on the battery, and the battery is covered with an additional protection, additional thermal cover. And then there is a strip which goes all the way up and then is put on here. You don't see this, but what you notice is that the battery is slightly longer. Now, these are batteries that can be sold independently, and you can use them anywhere you want, and that electronic circuit gives under voltage and over voltage protection. So even if you exaggerate draining the battery without any intelligent circuit, the battery will not die, because under 3 volts or 2.9, the MOSFET will, there's a little MOSFET inside, it will cut off. So, okay, anyhow, if you if you solder on this kind of top, you'll be overheating it very easily, because it doesn't have a lot of thermal capacity, because it's actually decoupled with the battery. And you could ruin not only the Polyswitch, but also the seal underneath. There is a little seal here. This stuff is actually stuck on. It's crimped on. You can't see it. If you remove the cover, I have another battery, but not here. Well, if you remove the cover, you will see that the crimping ends here on the top. So you can't actually see this part. You can feel it with your nail. Now, when you're transferring the heat, there is like a little gasket in batteries, in many batteries, even in lithium, in nickel metal hydride, and it's kind of spring-loaded to keep the pressure under control. If the gasket is overheated, or if the battery is overpressurized, it will vent. That is to avoid explosions. Otherwise, there would be chaos out there. So battery, once it's vented, it's lost its hydrogen positivity. Let's say the ions will not recombine balanced, and all the battery it's wasted. So basically, it protects you from explosion. Basically, it's the explosion protection. But if you overheat this, the battery, these batteries, the lithium ions, not the metal hydride, not the lithium polymer, but the lithium ion pure, they are pressurized. And so if you overheat it and the gasket leaks and you don't realize it, the battery will die. And that's not good. So when you solder on these batteries, on any battery, especially the positive terminal, you have to keep the soldering iron on it as little as possible, and probably lower the temperature, but don't stay there like for like tens of seconds, because you're killing the battery and there's nothing you can do to recover it. So spot welding, back to the spot welding, of course, avoids all this, because you just put on a little strip and spot weld it there, and you have an instant good connection. Well, supposedly good connection. You gotta test. For example, this is industrial spot welding, and as you can see, even if you pull it, it's very well welded on, and you can see it because if you start pulling, the where it's welded, it will start breaking. So what I usually do, I don't really pull at an angle because that's how you're going to break it, but try to gently rock it a little bit up, back and forth. If you can start making some movement, then you'll break the weld, and that's the best way to detach it. If you just wrinkle it off, then you're gonna cut the weld, and these little pieces will remain on. Another thing is that when you weld, you should, especially when you're soldering, add the double protection. You see here there is this little white isolation ring. This is good, and it's very important because, of course, when you weld it across, let's say you have like some high current usage or there's some problem, the strip will kind of overheat and it can melt the insulation. And if you melt and go through the insulation, you have the negative part of the battery here because it reaches all the way up and it's crimped here. Then you'd short it out. So this little ring here is very important. They sell additional rings, adhesive rings, also on eBay or on AliExpress for 18650s, and you can just stick them on. I usually stick them on also when, especially when I'm soldering, when I need to repair something, because it gives you more thermal protection on this side. So that's also important if you want to kind of like have further protections. As I said, soldering these batteries is never a good idea, but you know, if you do it fast and keep your soldering iron temperature control under and use a flux, then you can reduce that time and it will help save your battery. Of course, on the other hand, if you exaggerate with current on your spot welder, you will puncture it, and that actually does the opposite of strengthening it. It's going to weaken it, because the point is not to puncture it. The point is just to get that spot. And I mean, it's very indicative here. If you look at these welds, these are really perfect welds. You should, what you're trying to achieve is that. But I must tell you, you cannot achieve that spot accuracy with a manual spot welder, or like these very cheap welding things. These are the energy calculation it's done by time, as I said, and based on the battery you have, the leads, the contact, the energies, always, the joules are always different. So you never know how much energy you're transferring here. Professional ones, they have a current sense, and when you insert that amount of energy, it's always that amount of energy. But as I said, it's a totally different device. It's more complicated. If you need to do some welds at home, it's fine, it's not a big deal. But it's interesting to see how these welds are. And as I said, you see this circle, that's basically the contact. And if you note, they're all four, because I have 4 little welds here, they are all 4 perfectly circular and straight. That tells you that the machine is welding exactly from the top. And the weld contact is not in the middle of the circle. The weld contact is the circumference. That's what's welding. And why is that? Because the weld, if we were to contact everything, there would be, let's say, less temperature, and the weld would be less efficient. Because remember, this welds because of the temperature. And you are melting instantaneously these alloys, and that's why they weld. But if you have a very thick and a wide surface and it's all making contact, you're going to use more current, right? If you want to weld it. But if I have a circular contact with a concave electrode, the outside will weld, and that is just as strong as a complete weld. This is done with all the tests they did and everything on welding. It's actually interesting. There are a lot of documents out there with, the pros and cons of various welding systems. But this circular external weld is actually what is most efficient. So what is the electrode here it's actually concave. it's the outside of the electrode is a little bit, it's slightly further extruded than the inside. And funny thing is, apparently when you use these electrodes, when they wear down, they keep that form. They are always slightly concave. I don't know, it's probably an electrochemical phenomenon. Anyhow, as you can see, the outside and is welded. And when you pull, that outside where you have this kind of strong contact is the one that breaks. So when you try to peel it off, you're cutting where the external circumference of this weld is, and that's what is remaining. If you look at these, okay, I don't know if you can see it, but it's the external part that is there. You see, you can actually see the circular weld, and that's where it's the contact is. It's not in the weld itself, okay, in the center. It's on the outside, and it's very well welded. Of course, the inside is there too, but it's cut around. You know, these are like perfect welds. Of course, when you have an electrode like this, and you hold it in your hand, it's not possible. This is manual. So the best thing is to round it out, you know, so you at least have a more central contact, and that will basically, you know, keep the weld firm. Of course, you need to probably have more than 4 welds to have a good contact, because in that surface, you know, 1, 2, 3, 4, maybe like do 6 welds, 3 couples, which is better. Yeah, you can do some testing anyhow. So those are my, let's say, 2 cents on the whole welding and battery situation. Well, I've ordered some strips too, of course. I have some other strips in my lab, but I didn't bring them home, but I will do some more tests there maybe. Anyhow, I have enough, I did enough testing here, and as I said, I think that basically, well, I think this is the maximum this thing can drive. If you have a fully charged battery, 40 milliseconds is I think it's its limit without doing some damage, because of the problem is that the internal resistance of the FETs is significant, and it starts ramping up when you really start driving them, the current through them. So as I said, when you have some spot welders with maybe, I don't know, 20 FETs or something like that they're all matched, the thing is that the more they are in parallel, the less internal resistance, of course, you will have. So they will, let's say, dissipate less heat, and you know, your weld will be very, very strong. The current that will go, the instantaneous current that will go through it will be very high. So that's basically the difference between more and less FETs. Of course, the battery is very important, because if you have a weak battery, you're going to start ramping up the time, increasing the time, and that will only just increase the heat because of all the losses, and the FETs aren't going to be happy about that. And the weld, well, yeah, you might be able to get some welding done anyhow, but as I said, this thing should be very instantaneous. It should be, you know, very, when you start seeing some glowing and stuff like that, it's the limit. It's the limit. Otherwise, you risk on damaging even the puncturing the weld points, which is then a total fail, actually. Okay. Some other information. I did some checking on the original IC, which in my case it died. I have no idea why, but okay. And other people told me they had also problems. Where did I put it? Oh, here it is. This I did some checking, and it's a 20-pin dual line, and the only outline with this kind of outline, the ones that I found, and was also written by someone, is the ST Microelectronics STM8 series, 8-bit. Let's say they call them the value series. The 103F, which is it has I think 8K memory and some EEPROM on it. So this, you could even save some stuff on it, like, you know, if you want to save some settings, but I don't know. So let's say that it would be possible to write or you know, develop a code for the original STM, so that maybe people can update theirs if, you know, because this version has actually not really any safety feature. The older version, the BK whatever, the other one that has different graphics, and the screen is actually on the right here, there's a maple weld, something like that. That has, if I'm not mistaken, an EEPROM on board, and it saves some states, and it has the other problem that, you know, you need to do the cap fix. But apart from that, it apparently works pretty well. This one, as I said, I had some problems. It would weld, it wouldn't weld, and then it just blew a FET, and, you know, I was like, okay. And so I removed the FET, and, you know, then the whole display died. I don't know. So they are like made by two different developing teams, I'm sure, because even the graphics is different. So this series, which goes from BK to BL, is BK11, then they did a BK18. The BK18 has the resistor fix, which I did underneath, you know, with the dodgy wires. They actually implemented on the motherboard. So that was fixed in the BK18-2L, I think, or something like that. And then there's a BK20, which is a later revision, but I haven't seen the details, but I think they're basically the same. So I don't know. I think that this series needs a better software. The other one probably is okay like that. So I don't know if it's of any use to work or waste some time to develop from scratch an open source version for this microcontroller here. But yeah, maybe it could be useful, because there are programming headers on this board, and so if you have the ST programmer, this little USB programmer, it's pretty cheap. I think you can get it for 3 or 5 euros from China or somewhere. I have a couple, and you could reprogram it yourself. So I don't know. I was just thinking about it. If I have some time, maybe I'll look into it. I was checking it, and the libraries and everything depends on the development IDE, you know. Anyhow, so back to this version. Okay, apparently everything is working. I just wanted to just fill in these little concepts of this spot welding, and how industrial spot welding differs from actually, let's say, hobby spot welding. It's kind of this, the concept is the same, but as you can see, the machine is pretty different. Even if it's talking about high current in a weld, it's the electrode is very important. So this is all copper to minimize losses, of course, and the end here, they give it to you, and it's flat, but it's not to be handheld. I don't know how to explain it. It has to be held by the machine flat down, and then you can have a flat top with this little circle on it, as you can see on the batteries. If you don't have that, and you're spot welding by hand, yeah, you need to round them off, because if you don't, you should be spot welding vertically. If you do it like even on a small angle, all of the current will pass through that little contact that you made, and the weld will of course weld, but it won't be as strong as having a little larger surface contact with a rounded edge. Of course, it's a little bit more tricky. You need a better, how can I say, like maybe more current. But yeah, the weld will be a little bit different, will be stronger. Just don't make a hole, because when you make holes through the weld, then you're lost the, let's say, the structural integrity, and of course the contact point will not be so good, which is what you want. So, okay, I'll give you some further updates if I do some more tests, but basically I think that this will be more or less the definitive version, and I will post the code somewhere, so if you have some problems and want to modify the whole MCU, you can do it. As I said, most people just have the driver problem, so that can be fixed by checking the resistances and the resistor that's on the MCU, which is 1K, that comes out of pin originally of pin 19 of this MCU. And apparently many people have told me that sometimes it works, sometimes it doesn't, basically, which is what was happening to me when I found out that the resistance divider circuit on the back, which is only on this version, wasn't done very well. So then the other revisions should be fixed, but apparently the problem is still there. Unfortunately, I don't have any. I ordered a couple more. They're cheap, so I said, okay, I wanted to look into it from different sellers, just for curiosity to see what arrives. I think one will be the maple weld version with a display here, and that I think was the first type. And maybe I'll get another one of these, but a later revision, so I can check that out. I don't know. I'll see when I get them. Bye for now.